Hi, I'm Shane. Welcome to my shop. Welcome to my channel. Today we're going to be machining these. This is a small uh, precision spacer, magnetic, for my 4-jaw chuck so that I can do a job that requires me to use spacers on my 4-jaw chuck. I'm machining a wheel spacer for a friend, and it's the same thickness as the jaws that I have, each stanchion on the jaw. So I needed a spacer. I opted to make, I have 500 thousandths jaws. I wanted at least 250 to 300 thousandths. Um, I opted to go for 300 thousandths of actual purchase material left on the jaws. So I machined 200 thousandths spacers. Uh, and the preceding video is going to show you how I did it. And there's some cool machining. There's some hogging off aluminum. Uh, should be a good time. So I will make a note that the audio was kind of sketchy, here and throughout. Um, Wireless mic system that I have is something's wrong with it. So I ended up not using it. I'm not using it right now. I'm just trying to speak louder. um, the belt on the milling machine, the main cone pulley belt on my Bridgeport style jet on my Bridgeport round ram mill is it's whining pretty hard. It's getting gummy, needs replaced. So forgive me for that. It's I honestly wasn't sure quite what it was for a while, but that's what it panned out to be. So I'll be tearing into that here soon too. So I guess with all that being said, move on to machining. All right, so what I got here set up is this face mill, recently acquired. Looks like it has TPG inserts, and I tried cutting it on the other side uh, with all 4 inserts, and as usual I ended up pulling them all off because they're just not all in the same plane. Yeah, so basically we're using it like a glorified fly cutter. Gonna be spinning at 5,440 RPM. I'd say somewhere around 3 or 4 inches per minute feed rate. Keeping lubricant on. WD-40 is what I'm gonna be using for lubricant. I'm only gonna be doing a couple thou passes just to true this piece up, make it look nice. I mean, you could use like a PCD inserts, which is a polycrystalline. It's like a diamond, cemented diamond crystals. You could use that and obtain a better finish, or you could use an insert that's primarily used as like a scraper, like a burnishing insert. You put 2 of them on and 2 cutting inserts to try and wipe away the chips. We're trying for a halfway decent surface finish. But I've obtained fairly reasonable, actually I think really good results with the fly cutter setup type situation that I have going on now. So I'm going to go ahead and square up all the sides, and then I'll mark the piece out to the 1.5 inch sections. I'll go a little bit proud of them so I can face those in yet. And yeah, get all the roughing in done, and then I'll mill the centers out, mill them to accept the neodymium magnet, and should be pretty well set. We will check them on the surface plate then to make sure they're all reasonably close to the same thickness. Um, and then I'll proceed to use them on my 4-jaw chuck to true up some wheel spacers for a buddy of mine. Alright, I'll get fired up and bring you back. Not too shabby. Alright, that's a good start. Take you over to the bench real quick, break the corners. Alright, so I just use one of these. Sometimes I'll use the little Noga or Enco style, but more times than not, this is my go-to. Relatively simple. Flip it. Do it again. Takes all your burrs off. Flip it. Nice piece there. So that's our start. Now we got to cut it in 4 pieces. Knock those pieces down to 1.5 inches. And then the chuck jaws are 1.25 inches. So we'll knock them down to 1.5 inch pieces, and then we'll notch them down to our 200 thou thickness here. And that'll be just about right for my jaws. So I guess I'll get it marked out quick, get it cut off, set back up in the mill, and get all these pieces, squared up on the ends. And then we can set them up in the mill and cut our 1.25 inch through. Alright, hang tight. Alright, so got set up on the old Walker Turner metal cutting bandsaw. I've measured out 1 5/8 inches. I'm looking for a target around 1.5 inches, so that'll give me a little bit of material to square up on the mill. I'm just going to cut 4 pieces, call it a day. Then we'll get them squared up in the mill, get them all looking good. Then we'll cut our notches, and then we'll cut our recesses, and so on and so forth. So here we go. WD to lubricate it. I cleaned the table really good so as not to gall up our nice surface finish. And I put my best surface finish towards the top, so there's no chance anything's going to mess it up. So here we go. Alright, it's 4. Alright, so what I got going on here, I cleaned them up. I took them on the little granite inspection plate. These are all within, say the furthest deviation was 1 thou, but for the most part you're within 1/2 thou. And that's probably this little scuff right here that happened on the bandsaw. So we'll clean that up. But that caused a little bit of an issue clamping these in. And I wanted to make a point. The setup I have here, it's a good setup. I don't know if I'd trust it for more than just what we're doing here, dusting, squaring things up. Um, this is a piece of cardboard out of the back of a notepad. I took that out of Joe Piezinski's book. Um, Figured try that out. Never tried it before, so we're gonna see what happens. The idea is it's dense enough that it holds firm, but it compresses enough that it grabs them all evenly. I did square these up with a little Starrett square, so let's see that or not. They're dead square. The top sides are all in between. I marked the top sides. That way you know that's the side you want on top. That's what you got to work around. Try not to scuff that. Try not to leave apprentice marks in it. And you know which side you're gonna machine the channel out of, or any of the operations here forth. So we're gonna try her. We're gonna see what happens here. We're just gonna skim it, square them up, measure them, and we're gonna try and hit a somewhat nominal size that would be easy to divide, because we're probably gonna use a 1/2 inch end mill, take the middle out, and then step it over, front and back, to make our 1 1/4 inch groove. All right, let's get going. See what happens. I'm down with that. Pretty nice. Interesting. Ugh, that's how you done. Decided I'm too far off from the nominal size I wanted to get, so I'm just gonna take off whatever it takes to smooth these out and do the math, find the center, and go from there. So this will be the final step of making the square blocks, well, square-ish blocks, rectangular blocks, cube-like entities. So I'm gonna just face these in real quick. I did the same thing as the last, squared everything up. Still using cardboard. That seemed to work really well. So for small stuff like this, I'd recommend it. It actually worked really, really good. It's no different than the old trick, with a piece of wire, copper wire, aluminum wire, on a mill or in a shaper. Just this is a lot more readily available for me, and it's seeming to hold really, really tight, and it seems to hold everything really, really square. The one thing that I'll note is jaw side. If you don't know that, now you do. But your static jaw side, your fixed jaw, that's what's locating everything. So be sure not to put anything on that side, the wire, the cardboard, the dense cardboard. So that being said, fire up. I'm going to take my last couple cuts here, and then we're going to figure out where center is. Alrighty. Looking pretty good. To break the corners on them yet, but I'd say they're going to be a nice looking little part for me. If you guys make some, it'll be a nice looking little part for you. Alright, I'm going to break the corners on those, get a solid measurement with an actual micrometer, and see where the middle is. I'm going to change out to an end mill and take a chunk out the middle. All right. All right. We lost a little bit of audio there. It was intermittent. I think I have the problem fixed now with the wireless mic system I'm using. Uh, so where we're at now, this is kind of just a general idea. This is the overall width of the part. This is the center of the part, 797 thousandths. This is the depth of the part, 935 6/10. So what we need to do now, we need to locate this edge from here to here. And we need to move over our 797 plus half of the half-inch end mill, so 250 thousandths. Translating to 1 inch and 47 thousandths. And we're going to be going to a depth of 735 thousandths. We'll be using the half-inch end mill. We need an 1.25 inch hole. Well, the groove needs to be an 1.25 inch wide. So we'll go down to within 5 thou of our total depth. So we'll go to our 730 thou, and then we'll work on moving out 375 thousandths in either direction to give us our 1.25 inch. And once we know we establish that, we'll finish the bottom out lightly with some finish passes, and then flip it around, set up our stop, and punch our holes. They're going to be 110 thousandths deep because all of our neodymium magnets are between 103 and 104 thousandths thick, so that'll give us a little bit of leeway for our Loctite, and make sure that we establish a flat surface for mounting them on the chuck jaws. So the way that I have grown to set this up, I used to always use the your center finders or your edge finders, and anymore, I think probably because of the use of the horizontal mill, I just set up, real gently. There's a 5 thousandths feeler gauge, and it's just a hair bit of friction on it, just a little bit. So I know that I'm 5 thousandths away from the edge of that piece of material. So when I set my zero, I just dial back an extra 5 thousandths before I go dialing in. And I will establish the same with my Z-axis. I'll do that the same way before we come down our 730 thousandths. Okay, I'm going to get centered up, and then I will bring you back. Alright, so I established middle off the edge of the part. Once I got to the middle, I reset at 0. So I know, where I'm at and how far out I have to go. And I established my 0 with the top of the part. Or actually the bottom of the part. Kind of running low on WD-40, so I got some rapid tap and put it in the Eagle 66 pump oiler. We're going to see how that works out. We're going to be moving the table up to machine this 100 thousandths at a shot, and see how that treats us. All right. that sound, I determined the belt's getting really gummy. My actual cone pulley belt. So that's going to need replacement. I would really like to finish this job. So we're going to go as far as we can. We only got one more operation left. It's going to require cleaning all this up. If you haven't seen, I'll show you. Yeah, we made a mess. A little bit. That's fine. A pretty nice finish on there. See that well or not. So I'll get those out, get cleaned up, see where I'll locate my center again and set up a 3/8 end mill and just touch off, bringing in that 110 thou I talked about earlier. Then we'll be ready to glue some magnets in. So hang tight, I'll bring you right back. Alright, so I set a stop. I set my 0 as it contacts the workpiece. And I'm just gonna hand advance 110 thou down, and then put my neodymium magnets in with the Loctite 480. It seems to be working good on a test piece, so I'm gonna try it out. I'll get you set up on the stand here, tripod, and bring it back. Alright, sometimes I want to make a piece extra pretty. And you can see how rough it is from the deburring. I deburred with a file real lightly. You can see the teeth again. Aluminum will load stones and files up real quick, so I try not to stone too much. So I typically run a file over it light, and then come in on like a white stone like this, and just see, that starts to really smooth that up. I don't know if you can see or not. That's a lot smoother. Lost all the teeth out of it. So now it's just super slick and shiny. Relatively nice piece. So I'll go ahead and do that on all the corners here. We're going to brake clean them off. I may scratch some teeth in the bottom of this hole, so I have a little bit more, bite for the Loctite. I guess I'll do that and I'll bring you back. Alright, so I broke all the corners. You can see they look, yeah, you can see it a ton better, nice and smooth, nice surface finishes. I've checked the depths to make sure they were all at our 110 thousandths, so that these 103 to 104 thousandths thick magnets clear with a little bit of clearance, so they don't teeter. I've brake cleaned the holes. I've brake cleaned the magnets, and now we're going to put a liberal amount of this Loctite in the holes. I'm going to drop the magnets in. And what we'll do, we'll wipe it off with brake clean when we're done here. That's a lot. But I want it to fill that hole really good too. Alright. This stuff is supposed to be instant adhesive, but it takes a minute to see how that's surrounding it. Now real quick, get a little bit of brake clean on a rag and just wipe it down. Ooh, that was a lot. It's worth mentioning, I could not find in this whole shop a 10 millimeter end mill, which is the size necessary to do this. So we went with a 7/16, so that's why they're just a little sloppy in the holes. Not a big deal. It's not depending on the magnet to hold anything once it's chucked up and everything. It is somewhat depending on these sides to maintain, keep it on the chuck, and centrifugal force against the outside of the jaws. I would only use something like this if you were clamping something from the outside. It's going to drive me mad that they're not centered. Nobody's going to see them, right? Except for you guys and me. Alright. When it's starting to dry up, we can flake it off a little easier. We just don't want it setting up too much. A nice pretty surface finish. Alright, we're going to let them dry. Maybe give them another wipe down or two. Try them out on the lathe, see how they work. I think it's a win though. Alright, we'll let them dry, bring you back. Alright, they had a couple minutes to dry. Looking pretty nice. Moment of truth. See if they fit the jaws nice. Whoop. I kind of like it. And of course, you'd only want to use this in the orientation where the jaws are flipped. These ends will keep it from flying off. Centrifugal force will keep it tight against there, and that'll give you nice even spacing if you need to space a part out, which I need to do to machine these, and that should leave me clamp on the outside. Fair amount to clamp on yet. Lathe only spins 480 RPM, so I think we're going to be okay. All in all, I think I'm happy with them. They look good. They fit perfect. yeah, I hope you guys enjoyed. I hope you guys can use some of the information or the idea. And I'll see you on the next one. Thanks for watching.